welcome to our Python data science tutorial series. Today's episode is all about NumPy, the go-to library for numerical computing in Python. So by the end of this video, you will understand how to use NumPy for creating arrays, performing mathematical operations, and managing multidimensional data efficiently. So let's get started. So the question is, what is NumPy? So NumPy is the short form of numerical Python. NUM stand for numerical and PY for Python. So it's a Python library designed for high performance. Here we can also write as well. Designed for high performance numerical computations. So it's a backbone of many data science and machine learning work. And NumPy makes handling large datasets easier by introducing the array. So, a faster and more memory efficient alternative to Python list. I will share this file with you guys so you can find the link from where you can download the file. It's a backbone of many data science and machine learning workflow. Handling large datasets efficiently. Okay, now the next step is how to install the NumPy library. I hope you guys already installed the library in our previous video in which we set the environment for data science. So again, how to install the NumPy from Jupyter Notebook. Here you can see, write the exclamation mark, write pip install numpy, sorry, numpy, then run the code. So I run the code using keyboard keys shift plus enter. Now here you can see the seconds. Okay, so I already installed, so that's why it show the requirement already satisfied. Okay, so once installed, so let's import it into a Python. So how to import? Use a keyword import, then write a library name numpy as short name as np. Okay, so our next step is how to create a numpy arrays. Okay, so first we declare a variable. Variable name could be anything. So I write array equal to, now how to create a array. So use a keyword np, which is the library name, dot array, use open and close bracket, then square bracket, then write the numbers 1 2 3 4 5 6 7 and so on. Now print the array a double r. Now here you can see the array is showing. So this is a basic one-dimensional array. We will mention here this is a one-dimensional array. So unlike Python lists, NumPy arrays are optimized for numerical operations. Okay, so now let's see a two-dimensional array which is like a matrix. So how to create this? That I will comment creating a 2D array. So first we declare a variable matrix equal to np dot array. Now open and close. Okay, now there is a little bit difference. We use a nested square bracket, the first one and the second one. Okay, so 1 2 3 4 5 again, 6 7 8 9 10. Okay, now print the array matrix. The number of, now you can think of this as rows and columns just like a spreadsheet or matrix in math. Okay, now key array operations. So NumPy arrays allow you to perform element wise operations easily. So here is an example. So first we perform the arithmetic operation. Array, ARITHE. Okay, so again we declare a variable array1 equal to np dot array 1 2 3 4 and 5. Okay, now we declare a second variable in which the arithmetic operated array will be stored. So array2 equal to array1 into 2. Okay, now print the array ar2. Now here you can see the value of array2. This is the value of array2 which is stored in this variable. Okay, now this 2 is multiplied with each value of the array1. So this is the multiplication. You can do this for the adding two arrays. Okay, now we add two arrays, the array1 and the calculated value of array2. So how we can do this? Simply declare a new variable array4 equal to array1 plus array2. Now print. Okay, now here you can see. Okay, first we will comment this one. Now here you can see the summation of these two arrays is 3 6 9 12 15. Now I'm uncommenting this for better understanding. Now 1 plus 2 equal to 3, 2 plus 4 equal to 6, 3 plus 6 equal to 9, and so on. So I hope it's simple, right? So these operations are extremely fast, making NumPy a great choice for numerical tasks. Okay, now we discuss the useful functions of NumPy. So NumPy comes with a variety of built-in functions. So let me show you some of the most commonly used ones. So common NumPy functions. Okay, declare a variable array equal to np dot array 1 2 3 4 5 and 6. Okay, now we need to add these elements. So sum of elements. Now how we can do this? Print np dot sum array. Run the code. Now here you can see the answer is 21. So no need to be confused. You can also do this. Some variable name could be anything. Now just write the variable here. Again the answer is same. Okay. Okay, now if you want the mean of this array, so how we can do this? Mean of element. So declare a variable mean equal to, sorry, equal to np dot mean array. Now print f with proper message, mean of the element is mean. Now run the code. Now here you can see mean of the element is 3.5. We can also find the standard deviation of the element. So how we can do this? Standard deviation. So std or the short name np dot std array. Now print f std of the element is std. Now run. Now here you can see the standard deviation of the element is 1.7. So these functions are incredibly helpful when working with the numerical data sets in data science or machine learning. Okay, so NumPy also supports multi-dimensional arrays which are useful for working with matrices or tensors. So now in multi-dimensional array we create 3D array. So how we can do this? Creating a 3D array. Variable name could be anything. So array underscore 3D equal to, the syntax will be same as the two-dimensional array. Square bracket, nested square bracket. Now this one, this one, Okay, now one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now print the array 3D. Now run the code. Now here you can see the multi-dimensional. Okay, with just a few lines of code you can manipulate high dimensional data efficiently. Okay, now NumPy array support advanced indexing and slicing, allowing you to extract subset of your data as we discussed in our previous video how we slicing the arrays. Okay, indexing. Now we need to create a variable array np dot array this 10, 12, 13, 3, 4, 5. Okay, for better understanding I will create an indexing how the data is saved in array. So comment in memory the values are saved. Okay, the index is starting from 0. This value is placed on the 0 index. This one was on the first one. This one is on the second one, third, and fourth. Okay, now I am getting the value of index 2, which is 3. Now how we can achieve this? Print array square brackets. Now enter the number of index 2. Now here you can see on the index 2 the value is 3. For the 76 we use index 4. How the index is working? Okay, the next thing is slicing. So we already discussed in the last video. If we need a value from 12 to 76, now how we can achieve this? Array new array equal to arr. This is the syntax for slicing. If I am not writing on the left side and enter the value for the right, for example I am writing 4. Now let's see the result. New array. Okay, now the value is started from index 0 and skip the last value on the fourth index, which is 76. If we are getting the all values, then write 5. Now here you can see we get all the values. If on the left side I'm mentioning from where the value started from, so I put the index 1. Now here you can see 0 index is skipped. If we are removing the right side value, it will show all the values which is starting from the index 1. Now here you can see how the slicing is work. Okay, so Next, how slicing is working in 2D array. Slicing 2D array. So matrix. Okay, I'm already. This is the two-dimensional array. I'm also adding the third one as well, 10, 11, 12, 13, 24, and the last one is 45. Okay, now matrix this mm, one, this, then this. Now here you can see we are getting only these two. Why? Because we are skipping this one. Here we mention the first one. And from each array, like we can say from each row, the first value is skipped. Okay, now we change the values from 0. Okay, now here you can see this right value, this one, the first one value is for the whole these values. If you want to start from index 2, index 1, sorry, so you can mention 1. Now look, this index 0 is skipped, and this value is mentioned starting from the index 1 in each row. Okay, now we change the value again, 2, and I'm here change the value from 2. Now let's see. Now here you can see the value only 25 and 45, 24 and 25. Why? Because I'm mentioned the row which comes on the index 2. This one, this one comes on the index 2, so that's why it's showing only this row, and row start from index 3, from 24 and 25. So with slicing you can target specific portions of your data for further analysis. So that's it. So today we explored how to create arrays, perform mathematical operations, and manipulate multidimensional data efficiently. Mastering NumPy is an essential step in your data science journey. If you want to explore more about the NumPy, so I will mention the link in the description. So in our next video, we will discuss about pandas, the ultimate library for data manipulations and analysis. So don't forget to like this video, subscribe to the channel, and hit the notification bell so you don't miss any updates. So thanks for watching, and I will see you in the next tutorial.